Hello everyone, my name is Kan Ho. Today I am going to present about our research paper related to the classification of 14 thoracic disease using chest X-ray images based on Ensemble knowledge distillation. My presentation will be divided into four main parts. The first part, we will briefly go through the introduction session to introduce the chest X-ray dataset. Then we will move into the materials and methodologies, which is including the deep learning-based approach for the 14-class classification. And then we will move on to the experimental result. At a final part, we will include our paper with a short discussion. So let's get started. So as you can see here, this is the 14 random samples associated with the 14 thoracic disease in the chest X-ray dataset. For example, you can see here like cardiomegaly, consolidation, or nodules, or pneumonia, or pneumothorax. So some of them may be familiar to you. So our motivation to build the model is to generate weekly supervised multi-label lung disease classification, and also to support the visualization of the lung region or the disease region. We are trying to cooperate between the CAM or saliency maps to visualize those highlighted regions. So this is our proposed future integration framework for the COVID-19 classification, or this is called like Ensemble knowledge distillation. So as you can see, this is the chest X-ray input, and we will build two main blocks. The first block will be the teacher network. So in here, we apply the pre-trained DenseNet 121, which was pre-trained previously in our previous paper, also apply on the chest X-ray images. So those parameters will be transferred into this block called the knowledge distillation. And in this stage, we try to minimize the KD loss so that the parameters can be used to teach the student model. The second blocks will be here, like we call example of student networks. Instead of using only one student network at a standard KD, in here we integrate four main student model like mobile net V1, VGG19, ResNet 32, ResNet 50. So those will have different range or different parameters. We train the network, student network as a parallel branches. So those will be concatenated and will be fed into the softmax cross entropy, and also to minimize the KD loss here. So by this way, the combination of student networks can mimic the training of the teacher's model and to generate the higher classification accuracy in comparisons to the standard KD. Yeah, so this is how we propose our models. So as an experimental result, we compare the Ensemble KD with other existing study. For example, the base training that we apply for main student model here, and then this is teacher model. So it's pretty acceptable result, like 0.8% of accuracy for the 14 class classification. And we also do the self-training or standard KD, and we observe more higher accuracy compared to this one, like 0.82, and reverse AD, like teacher teach the student teach the teacher models. Or defective KD, like we train only very few epoch, so that it may not pretty good compared to other previous one, and we observe around 0.81 or 0.8. But if we apply the ensemble KD, which means the combination of the 4 student class here, so the teacher model here will teach the combination of the 4. So we obtain the highest accuracy, around 0.84 compared to the previous one. So to visualize the disease reason, like those here, we cooperate the CAME as well as the saliency map. So you can see here, it's pretty good to localize those reason. And also this also obtain the similar result. So this is the step that's very important to help the doctors or the radiologists to recognize the disease more faster in an affordable and inexpensive way using the deep learning. So at a conclusion, in this paper, we performed the 14 class classification test, and we compare the our proposed model like Ensemble KD with the standard KD, and the findings showing that the Ensemble KD perform better, and this method validate the important potential of the multiple thorax classification test for our near future studies. Yeah, so thank you for your listening.